Welcome back to Nick Does Maths. We are going to do a bit of mechanics here. We have a triple collision, 3 particles, 1, 2, 3. Let's see what's going on. Again, as usual, I haven't written the entire mechanics blurb down, but we've got a sketch to help us out. We've got 3 particles, A, B, C of mass m, 3m, 7m. The coefficient of restitution between particle A and B is 0.5, and we don't know what it is between B and C. A is hurtling towards B, who's at rest, and C at rest at u meters per second. Here's the thing, if there is a second collision between A and B, if there is to be a second collision between A and B, find the range of possible values of E. So what do we mean by that? A is going to hit B, some stuff happens. And then B will hit C, some stuff happens. And then after that, A and B will be traveling somewhere. What should E be to make sure that B will then hit A again? So A hits B, B hits C, then B will hit A. Well, let's see what happened. Let's go for collision number 1, A into B. Let's go collision A into B. So number 1 here. All right, so we got A, we've got B. All right, A is going at U, B is going at 0. Afterwards, this one will be going after collision 1 at U1. This one will be going at V1. All right. So the age-old classic of conservation of momentum, which is mu is equal to mu1 plus 3mv1, which we can deal with in a second. And then my coefficient of restitution, speed of separation, v1 minus u1, is e, speed of approach. All right, we need to solve these. The one I'm really interested in is V. I need both, actually. I need both, so I'm not sure why. All right. So how about I add these up? How about I add them up? U1 minus U1 disappears. So 3V1 plus V1 is 4V1, is 3 over 2U. So V1 is 3/8 of U. And we can also then get that U1 is minus U over 8. Take that, plug it back into, say, that one. Right? Yes. So that is going at minus U over 8, and that is going at 3U over 8. All right, cracking. Let's do the second collision. Right, so let's do collision number 2. We've got B that is now traveling at 3U over 8. We've got C that is not traveling. Afterwards, this will be going at V2, and this will be going at W2. I don't know. I've decided that this one's speeds will be U, that one's V, that one's W, and then based on which collision it's after. Like, whatever makes sense for you. Right, so 3m times 3u over 8, that is 9mu over 8 plus 0 is equal to 3mv2 plus 7mw2. Speed of separation, w2 minus v2, is e times speed of approach. Okay. Right, and as previously, these m's will cancel out. So how about I multiply this one by 3? How about I multiply this one by 3? 3, 3, and I'm going to change that into a 9. Just trying to conserve a bit of board space here. And if I add them together, what do I end up with? The V2s cancel out. Really, I don't care about W2, so instead, let's times it by 7. Let's times it by 7, in fact. And times it by 7. There we go. Let's times it by 7. So I will do this one, take away that one. So 3v2 minus 7v2 is 10v2. 9 u over 8. Okay. So we can get v2 from there. Now, importantly, in fact, I will write this. I'm going to write this in a slightly different way. All right. Now, why would that be important for me to have the minus in front of here? Well, so at the end of the day, A, after all my collisions, what's going on? After all my collisions, I've got particle B is heading this way at 21e minus 9 over 80u. And this one here is going at minus u over 8. This way they're both negative. So they're both heading to the left, u over 8, and at this velocity here. So what do I need to happen? I need u over 8 to be less than. If B is going to catch up with A, that has to be going faster than that. So 21e minus 9 over 80u. Now we can tidy that up a bit, divide everything by u. So we can times the whole thing by 80 over u. So that tells me that E has to be bigger than 19 over 21, and obviously less than or equal to 1. Just about squeezed it onto the board. Okay, so 1 collision, 2 collision, and then the key idea is comparing the velocity of B after the second collision and the velocity of A after the first collision. That needs to be faster than that. Because that one's traveling to the left, I wanted this expressed in terms of it being a negative. And that just helps me a little bit with the inequality. Woo! Nice. A little bit tight, but we got there in the end. If you enjoyed this, please don't forget to like, subscribe, hit the bell button so you can see when more of these are coming out, help you do a little bit of collision mechanics. A lot to keep hold of, but if we write it out, we choose consistent notation and keep the brain in check, keep the brain braining, it's not too bad. I will see you next time here at Nick Does Math to do more fun, further mathy style questions, A-level-ish, all around there. I will see you then. See ya.